All right, let's get started on section 3.3, measures of central tendency and dispersion from group data. Okay, so in this section, we're going to look at how to approximate the mean of a variable from group data. Of course, maybe define what group data is if you're not quite sure what that means. We're going to compute the weighted means. The most famous example of those is calculating your grade point average. But we'll look at another example. And then we're going to learn how to approximate the standard deviation of a variable, again, from grouped data. Okay, so far we've discussed how to compute descriptive statistics from raw data, right? That means when you see from raw data, that refers to raw data. It's like sort of the original set of data. Nothing has been manipulated, changed, it hasn't been reordered, it hasn't been rounded, there's no characteristics of the data that you're dealing with. You're dealing with the original data points, right? That's the raw data, unfiltered, undisturbed. But often the only available data have already been summarized in frequency distributions or group data. Although we cannot find the exact values of the mean or the standard deviation without the raw data, we can approximate these measures using the techniques discussed in this section. So it is an inferior process. If you have the original data and you can calculate the mean and standard deviation, then you're going to get an exact answer. So you would only apply these techniques in cases where you don't actually have the original raw data, or maybe just it would be too difficult to work with it if it's excessively large, and maybe in some cases you might be perfectly content with a decent approximation rather than a more precise answer. Okay. So the formulas we're going to use are here. They're both really identical. It's just that the only real difference is that for a population, we continue to use mu, right? And for a sample mean, we continue to use x bar. X bar, the sample mean, mu, the population mean. But notice that both formulas are identical. So besides the notation that we use, everything else the same. So this is equal to that, right? So if you're a little unsure of what this notation means, this giant sigma, remember it means that you're going to be adding whatever's in here. You add it, and there are little indicators, usually here and here, as I did before, to show you what that means. So this means the same as this. We replace the i's with a 1, plus, then we replace all the i's with a 2, and that's how we get this guy. And then we replace it with a 3, and then we replace it with a 4, and we keep going, and we don't stop until the end. Now, if this is a population, this should be capital N. Well, okay, where n is the number of classes. Never mind, it's not the number of objects in a population. Okay, so all the way out to n, and then same for the denominator, right? This means we replace the I with a 1, and then we replace it with a 2, and then a 3. Each time we're adding, so then we end up with this. And then up here is where the little indicator will tell us when to stop. So this is maybe a bit of a shortcut. A more complete answer would have been to say that it's Riemann sum as I ranges from 1 to n of f of I. Okay, so that would have been, that's the same as this denominator down here. And so this is that guy, right? These set of instructions say you're going to take the little I and replace it with a 1. Plus, take the little I, replace it with the 2. Plus, take the little I, replace it with the 3. And you just keep going until you reach the stopping point, which is up here. And so we stop when the little counter gets to n. Okay, so that's what this means. Now, the value of f is defined down here in this little ledger here. So x sub I is the midpoint, or the midpoint or the value of the ith class. So for us, it's going to be the midpoint. And f sub I is the frequency of the ith class. Good. N is the number of classes. All right, so both formulas are very, very similar, but what do they actually mean? What are we talking about, and what in the world is group data? So let's look at an example. Okay, so here's an example. Each year, Oscars are awarded to the best actress and best actor. Are the ages of those award recipients at the time of the award ceremony? Excuse me. Below are the ages of those award recipients at the time of the award ceremony. The question we want to consider is this: Are there major differences between the ages of the best actress and the best actor? Apart from being interesting, this issue is important because it potentially gives us some insight into the way our society perceives men and women in general. Okay, so here are the ages of age of the best actress winner for various years. So the first one recorded, whoever this was, 22 years old when she received her Academy Award for Best Actress. The next one was 37, then 28, then 63, then 32, so on and so forth. Whereas men, here we go, first one recorded here is 44. Somebody was 44 years of age when they got their Best Actor Award. Then the next year, somebody was 41. Next year, someone was 62, and so on and so forth, right? So we have two sets of data. And we want to calculate the information about these, right? We want to know, are these similar? Are there any differences between them? Can we say, no, there's no difference between men and women when it comes to winning the Best Actor or Best Actress award? Well, it's really hard by just looking at the tables, right? It's kind of hard to see anything, if there's any patterns or anything. So we're going to dive in here and get some characteristics of these populations. So they are, speaking of, they are populations, right? Because this is all of them, right? Of the best, if we want to make a list of all the Academy Award winners, these are it. These are all of them. This is not a random sampling of everyone that has won. Each year, only one male wins, only one female wins. So we're going to treat this as a population. Okay, so this is going to be population number 1. And we're going to call this population number 2. Okay, use the data from above to calculate the 4 measures of central tendency. There's one that says 4 measures, the 3 measures of central tendency. These measures can be easily determined by using, okay, so use your calculator to find the mean, median, and mode. Mode's going to be a little harder, as we'll see, but the mean and the median we can definitely do. So it'd be a great opportunity to practice and remember how to do this. Okay, so go over to your calculator. Okay, hit clear from wherever you're at. Maybe hit quit to exit whatever screen you find yourself in when you first turn on your calculator. Go over to stat, hit enter for edit, and then here's all your lists. Let's go up and highlight list number 1, hit clear and enter. Make sure that you're highlighting the L1. L2, use your arrows to get up there. L2, hit clear, enter. If you're missing too many of these, remember you got to go to stat and then hit setup editor. Hit enter, done. Good. Go back, enter, edit. There they are. Okay, so I want to list the first one. Let's match it up with population 1, and this is best actress. So I want one giant list. I don't want to recreate this table on here. I just want one single long list that has all of these values. And then over for list 2, I want to put all the actors. So 44, 38, 41, all the best actors go onto this list. Okay, so I'll get started on that. L1, it's going to be okay, I finished inputting all the values. So L1 here has the ages of all the best actresses at the time when they won their award. And then on list 2, reaching over here, I put the ages of all the best actor awards, right, when they won their award. Somebody was 32, the next, another year someone was 42, another year someone was 47, another year someone was 42, 37. Okay, so all of these values have been listed onto list 2. Okay, so if you'll recall from before then, to find all and everything I ever want to know about each one of these lists, we're going to go over to stats, go to the right, calculate, hit enter for one variable stats. You're going to hit second L1, enter, make sure that this frequent list is blank. Hit calculate, enter, and here it is. This is everything we want. So the mean age is 35.68. And then we also have 2 standard deviations. Again, remember, we're going to treat this as a population. This is all of them. And so it would be 10.99, 07, by default, say 4 decimal places. So let's write that down in this nice little table that's provided. Okay, so for the actress, let's put it in blue, that's fine. The mean is 35.6842. And to get the median, remember that to get the median, once you get your output this way, you can use this arrow. You want to go down there. So use these arrows and go down, and then there it is. The median was 33.5. Just going back over here. This is 33.5. Okay, remember the formula for these, how we found them. The mean is the result of adding up all of these numbers, 22 plus 37 plus 28 plus 30 plus 63 plus 32, all the way down. So add them all up, divide by the number of values, the number of entries, and that's how you get the mean. Okay. The median, on the other hand, is if we order these from the smallest to the largest, then the number right in the middle is going to be 33.5. Now, the reason why we have a decimal, or because there's a decimal, that lets me know that there is an even number of entries here, so the median is actually going to be the mean between the 2 numbers that sort of qualify to be in the middle. Okay. Now, the mode is a little bit more difficult. It's not easy to get it, not quite as easy to get it. Remember, the mode is the number that happened most often, and it's kind of hard from here to tell which is the number that occurred most often. Off the top of my head, I can see that 25 happened pretty often. Here's 25, 25, 25. 29 is pretty often too, 29, 29, 29. So it's kind of hard to tell which is the number that occurred most often. So there isn't an easy way to get the mode from the calculator as far as I know, but there is a way to make life a little easier, and that's to organize our data. If we go back to stat and then edit, we get back to this list. I can order this data. I can have my calculator organize it from the smallest to the largest. So stat and then sort. And then the A is for ascending from smallest to largest, and then descending from the largest to the smallest. Doesn't matter which one. Pick sort A, and then we're going to do it for list 1. List 1, close parentheses, enter. And now if we go back to that same list, it'll all be sorted from the smallest to the largest. Okay, so that makes it a little easier to count and figure out which is the number that occurred most often. So let's see, 1, 21, 22, 24, 25 is pretty often. 1, 2, 3, 4 copies of 25. So far, that's the winner. 4 copies of 26. 4 copies of 27. 4 copies of 28. Looks like four times seems to be pretty popular. 1, 2, 3, 4, 5, 6. 6 times the 29. No. Oh, 33 is pretty popular. 1, 2, 3, 4, 5. Nope, not quite as popular as 29. 3, let's see, that's 4, 5, 6, 7. Okay, looks like 35 is more popular. 1, 2, 3, 4, 5, 6, 7 times. And I think that's going to be it, right? So at least it lets me kind of go through the list in a more systematic way, so I can identify the ones that happened a lot. So 29 happened a lot, 1, 2, 3, 4, 5, 6 times. But we saw that 35 was going to be the winner. 1, 2, 3, 4, 5, 6, 7 times. So 35 is the number that occurred most often. And go back over here and highlight them. 35, where did they happen? 35. So here's 1. There it is. 1, 2, 3, 4, 5, 6, 7. 7 times, and that's our mode. 35 is the winner. Okay, so we have those 3 important characteristics about population 1, the actresses. Now let's repeat the same thing for the men. Academy Award Best Actors. So remember that all of that is on list number 2. So we're going to go to Stat, Calculate, one variable Stat, and we're going to do List 2. List 2, down, Calculate, and there it is. So the mean age is 44.0789, and if we slip down, we see that the median was 42. Okay, so let's write down those 2 values. So the mean is 44.0789, and the median was 42. Okay, remember the median, again, it's down here, so don't lose it. You got to use your arrows to go down. There it is. The median is 42. Okay, again, we want to find the mode, so let's organize the list one more time. Remember, this is list 2. So let's look at the list one more time. If you enter, see how that list is kind of messy, just the way I uploaded it to it. Okay, so we're going to go Stats. Let's sort ascending from smallest to largest. Just for fun, let's go the other way around. Sort descending from the largest to the smallest. And we want to do that to list number 2. Close parentheses, enter. Okay, so now remember, all I'm doing is I'm tracking which is the most popular result. See, from the largest to the smallest. So let's see which numbers happen very often. Looks like 62 a couple times, 57, we could do better than that. 53, 52, 1, 2, 3, 4. Okay, 52 can happen 4 times. Two, three, 4. Okay, 43 happened 4 times. Needs to be a tie there. Oh, 42 now is the winner. 1, 2, 3, 4, 5, 6 times for 42. Okay, 5 times for 41. 1, 2, 3, 4. Oh no. 1, 2, 3, 4, 5, 6 times for 41. And 1, 2, 3, 4, 5, 6 times for 42. So 41 and 42 are tied at 6 each. 1, 2, no. 1, 2, 3, 4, no. 1, 2, 3, no. No. 1, 2, no. 1, 2, 3, no. 1, 2, 3, no. 1, 2, no. Okay, that's it. So it looks like we have a tie. There were 2 different numbers. Let's go back up here. (41) and 42. 1, 2, 3, 4, 5. There's one missing down there. There. So 1, 2, 3, 4, 5, 6 times the 41. And then 1, 2, 3, 4, 5, 6. Oh. 1, 2, 3, 4, 5, 6 times for 42. 1, 2, 3, 4, 5, 6. Okay, they're both tied at 6 each. Coming back over here. That means that the mode has 2 winners, 41 and 42. (41) and 42 are the 2 winners, right? So we said this is bimodal data. There were 2 winners. Okay, let's spot them. 41s, let's see, there was, this one's 41, 41, 41, 41. 41. 1, 2, 3, 4. There's one more 41. And then 42s. 1, 2, 3, 4, 5. 6. Okay, so bimodal, tied with 2 different values. Okay, well, what can we do when we want to compare these 2 sets? What does this information tell us? Looks like the mean age of the actresses was a little lower than the mean age of the actors. Also, the median age of the actresses was a little lower than that of the actors. And also the mode. So on all 3 parts consistently, the results of the female population were smaller than the results of the male population. Okay, Hollywood seems to like favors to grant Best Actress awards to younger women as compared to men. Right, that's something we can consider. Now, what about the relationship between the mean and the median and the mean? Right, so in this case, the mean is larger than the mean. I'm sorry, the mean is larger than the median, and so in this case as well, right? And what happens when the mean is larger? The mean gravitates toward the outliers, right? So we have a situation like this. Oh, sorry, a situation like this, where the mean is to the right of the median, right? So we can assume that the data is right skewed, right? Again, I'll keep repeating this for a while because I think it gets really confusing. What does this little mountain mean? Remember that the horizontal axis is always the values of the data. So in this case, ages. So here we have horizontal axis. Wow, can't even do a straight line. This is going to be ages. And then the little curvature above, right, when we see something like this, it means that we observed a lot of values in this region. Again, you can kind of visualize this as little ping pong balls that kind of stacked against, one on top of the other, and then another little ping pong balls that are stacked on top of the other, like that, just little stack, stack, stack. So the taller the mountain is, the more often we saw that value. So the number right here is the value that we saw the most, right? Because it goes way up to the highest value. So just the taller this region, the more often we saw values, or in that zone. Whereas over here, as this guy comes down, that means that there were less and less values over in that range. Right, so maybe this is dancing around the, let's see, the mean. Let's say that this is like 30, and then the mean is going to be over here around, let's say this is 33.5, and then maybe over here would be 35.6842. So the bulk of the data is going to be over here, below this value, below the mean, but there's an outlier, right? There's outlier values there that are putting a drag on the mean and the median, but remembering that the mean is more sensitive to an outlier. It more easily gets attracted to outliers. Good. So for that reason, we know that this data is right skewed. Okay, the mean is bigger than the median, and that's for both cases. So our data is like this one. It's got a right skew to it. The bulk of the data is on the lower left-hand side. So yeah, there's going to be a lot of winners in their early 20s to late 20s, early 30s. But then there's a few outliers out here that are in the 60s and 70s that are dragging that median and the mean toward the right. Okay. So let's keep going. Okay, but now let's get to this group data thing, right? This was a nice little review on how you find the population mean and the population median. But what if, instead of the original data, the complete data, instead they give you a table that looks a little like this one here? What this is a table where we describe a range of ages, 21 through 30, 31 through 40, and then we have a frequency count to identify how often one of the female actresses landed in this little range of ages. So there were 28 females between the ages of 21 and 30. There were 30 females between the ages of 31 and 40, inclusive of their endpoints. There were 12 females within the 41 to 50 age range. And then there were 2, 2, and 2 in each of these. Okay? Just to spot them, let's find these. Which are the 2 females that were between 71 and 80 when they won their awards? 71 and 80. So let's go over here. Let's erase. markings. Okay, we're looking for two that are in the range between 71 and, okay, here's one, 80. And there's one other one. Oh, there it is. This person. Twice, two women won the Best Actress Award, and their ages land them in this category. One of them was 80, one of them was 74. Right? The 80-year-old gets tossed into this category, 80 and 74. These ladies go into this category right here, and that's why there's a 2 right there. Good. There were also 2 that were in the 61 to 70. 61 to 70. Let's find them. 61 to 70. 61 to 70. 61 to 70. '61 to 70. Here we go. So there's the 2. One of them was 63. The other one was 61. 61, 63. 61 and 63. 61, 61-year-old and a 63-year-old. Those 2 ladies are the ones that qualify under this, and that's why there's 2 values there. Good. Last one, let's just confirm this. 51 to 60. 2 of the ladies were between 51 to 60. 51 to 60. 60. There's the 60. And then 51 to 60. The other one is, oh, not 50, 51. So that one is not in the category we want. There we go, 54. A 54-year-old and a 60-year-old. 54 and 60. 54 and 60. So a 54 and a 60. These 2 ladies belong in this category, and that's why there's 2. Okay, well, if we keep going, we count through, we see that there's going to be 12 women that fall between the ages of 41 to 50, 30 women that fall between the ages of 31 to 40. Okay, so hopefully that means we have a pretty good understanding of what this table is indicating for us. And now, what if this is all we had to go by? We didn't have access to the original information. This is it. So let's come up with a way in which we can approximate, get a pretty good sense of what that population mean is going to be from this group data. Okay, so you know, let's go over here to these people. 2 people in this age range. I know that it's an age. What would be your best guess for these 2 people? We're going to guess. The best guess would be the value in the middle of this. Good. Same thing for these 2 people. 61 and 63 are the real ages, but if you didn't have the real ages, your best guess is going to be to use the middle value here for the ages of these 2 people. So we're going to find the midpoint value of all of these points. Okay, so that's what we want here in this 3rd column, midpoint values. So now remember, the way we find midpoint values is to add the 2 consecutive lower bounds together and divide by 2. So to get this first midpoint value here, we're going to take 21 plus 31 and divide by 2. So that'll be equal to 52 divided by 2, which is 26. So the midpoint value of that first one is 26. Good. All right, now the next one, well, we need these two consecutive values. So we'll use 31 plus 41, and then divide that by 2. We'll get 72 divided by 2, which will be 36. Okay, we start to see a pattern. That's usually what happens. Let's do the next one. 41 and 51. 41 plus 51 divided by 2. That's going to be 92 divided by 2, which is 46. Okay, and I start to see a pattern that emerges. 26, 36, 46, so I can just fill in the rest. 56, 66, 76. Good. Confirm that it all sort of makes sense. The middle value between these two, it's going to be 76. The middle value between these two, it's going to be 66. Okay, so that's how we find all these midpoints. Good, good, good. Once you find all those, you don't need this. You just need those midpoint values. Okay, next, what we're going to do is we're going to multiply the frequency times the midpoint for each one of these classes going across. So let's go backwards here. Let's multiply these two. So we're going to multiply the frequency with this 2 times 76. 2 times 76, which is 152. And let's think about what that means. 152. 152 is going to be the sum of the ages of those two people, or our best approximation of what the sum of the ages of those two people is. Right? So in actuality, right, if I have access to it, I know that the sum of the two people that belong there, one of them is actually 80 years old and the other one is 74. So if we add their ages together, they add up to 154. Right? That's the actual sum of their two ages. But remember, we don't know their real ages. So what we're going to do is we're going to guess. And we're guessing the middle value, which is 76. So we're saying, oh, maybe they're both about 76. Sometimes that guess is going to be a little high because for one of the people, their real age was 74. So 76 was a little high. For other people, that guess might be a little low. Like this person in reality was an 80 and we guessed 76. On par, they tend to balance out. And as you see, it ends up being a pretty good guess for the sum of the two people. So that's what this means. This is my best guess for the sum total of the ages of these two people. Good. And we're going to do the same thing for the next category. There are two people in there. You won't know what their real ages are, but it's somewhere in there. In reality, their ages are 61 and 63, but you don't know that. So you're going to guess. And the very best guess is to use the number right in the middle. So why not use 66? 66 is a number that's right in the middle. So if we multiply 2, because there's two people in that category, and say, well, you know, they both have about 66 years of age, 66. So now if we multiply those two things together, you get to 132. 6 times 2, 132. And again, that becomes my new best guess for the sum of the ages of the two people in that category. Now, since we actually do know the answer, we know one of them was 61 and the other one was 63, we know that their sum total is 124. Okay, well, as you can see, this is going to be a little higher than it was supposed to be. Well, that's why this is an approximation. We're not going to get the exact answer. We're going to get something approximately close. So here we ended up with the value, 152, that was a little lower than the real answer. And here we are going to end up guessing 132, which is a value that's a little higher than the real answer. So as you can see, things kind of balance out a little bit. Sometimes you guess a little high, sometimes you guess a little low. And at the end of the day, you end up with a pretty good guess for what the whole thing is. Okay, so we're going to continue to do this. Let's multiply the frequency times the class midpoint. So that would be 2 times 56 is 112. And then 12 times 46 12 times 46, which is 552, right? So remember, what does that mean? It's my best guess for the sum of all the ages of these 12 actresses that fall in this range. Some of them are 41, some of them are 50, and everything in between. So my best guess is going to be that, well, they're about 46, and there's 12 of them. So if I multiply those two values together, I get my very best guess for the sum of the ages of those 12 women. Then we do the same thing for the next category, 30 and 36. 30 and 36 multiplied to 1,080. And finally, 28 and 26. 28 times 26. Multiply it to 728. 728. Good. Okay. So next, what we want to do is add all of these values here. And this is the same thing as this this value that we need for our approximation for group data. Okay, so let's add up all these values. We got 728 plus 1080 plus 552 plus 112 plus 132 plus 152. I'm getting 2756, and that's the value that goes right here. 2756. Good. And next, we want to add up the frequency values. 28, 30, 12, 2, 2, and 2. And if we add up the frequencies, that adds up to the total number of women in our list. So I get 76. Okay, so this 2,756 is my best guess for the ages of all 76 women added together, right? The 728 was my best guess for the sum of the ages of these 28 women, where I'm using the middle of the class as my best guess for them because I don't know the real ages. Good. So now we just have to fill in this guy. The mean, well, it's x bar if we're dealing with the sample, or it's also, it's the exact same formula if we're dealing with the mu, right? Mu approximation, approximately. Now this notation like this is f It's getting messy here. This guy, mu of x sub I, f sub I all over some f I. Let's complete the. So this little squiggly equals is to indicate that it's an approximation, not necessarily equal to. And let's say that we have this thing, and it goes from I starting at 1, 2, and then how many classes do we have? We have 1, 2, 3, 4, 5, 6 of them. So we're going to do this from 1 to 6, and it's going to be equal to Fixi, and then divided, the whole thing gets divided by and then this guy is going to have I starts from 1 to 6 because there's 6 classes in my case of F sub I. Okay, I was just personalizing it a little bit. So this is the sum of all of these. So that's just going to be this number here, right? Just to really, you don't have to do this, but just to really highlight this, this is going to be F1 x1 plus F2 x2 plus dot 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 dot, and we know we don't stop until we get to 6. F6 x6, 6 there, 6 there, and then the denominator is also F1 plus F2 plus dot 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 plus F6. Okay, so this first product, that's this one. We figured that out. This one here is 728. And this one here, that one is 1080. And so on. And the very last one is 152. Okay, so if we add all of these up, that'll be the sum of the numerator. And we already did that. Right? That table helps us organize all this information. So I already have that the sum of the numerator is going to be 2,756. And then the sum of the denominators, again, this F sub 1 is this first frequency, which is a 28. This is 28. Plus the 30 is this F sub 2. That one is 30. Dot, 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 dot. And then the last one, F of 6, that one was a 2. That's this one there. Okay, and then if we add them all up, we already did that. That summation is going to add up to 76. So we're saying that my approximation for the mean is the division of these two numbers. So let me go ahead and divide them. 2756 divided by 76 gets me to 36, 26, 32. 2632. Okay, so mu is equal to 2 is equal to 275, which is equal to 36.2632. Okay, so here is my approximation for the mean. Let's compare the basic original calculation for the mean in step 1 with the calculation of the mean from the frequency distribution tape 2. How close are they? Okay, so we saw from before when we used our calculator to find the exact answer. For the women, the mean was 35.6842. 35.6842. So this is the actual answer, the real value, the real mean. Come on. Seriously? real mean, whereas this is an approximation. My approximate mean is 36.2632. I say that's pretty close. Good. So it's an approximation. Not exactly the same, but fairly close. All right, that's how we use grouped data to approximate a mean. Okay, so now let's take a look at measures of central tendency and dispersion from group data. We're going to look at how to compute the weighted mean. So the weighted mean, and we use x bar with a little sub w to identify weighted means. So the weighted mean of a variable is found by multiplying each value of the variable by its corresponding weight, then adding all of these products, and then dividing by the sum of the weights. Right, so it can be expressed using this formula. Remember that giant, this notation here, this giant sigma means it's the sum of these multiplications, and then you can expand that out to be this. So replace the I with a 1, so we get this product. Replace the i's with a 2, we get this product, and so on and so forth. And we do it for n, for n values, and then we divide by the sum of the weights, of which there will be n of them, right? Where w is the weight of the ith observation, and x sub I is the value of the ith observation. Okay, so let's do an example with this guy. Let's say, this is a classic example, we have something like trail mix. Bob goes to buy the weight nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate-covered peanuts, and 1.5 pounds of cashews. The raisins cost $1.25 per pound. The chocolate-covered peanuts cost $3.25 per pound. And the cashews cost $5.40 per pound. So, what is the cost per pound of this mix? All right, so let's organize our data. We're talking about raisins, so we have 1 pound. Pound of raisins, and the price of raisins was $1.25 per pound, right? And then we had 2 pounds of chocolate covered peanuts. Chocolate peanuts. And the chocolate covered peanuts cost $3.25 per pound. And finally, we have cashews. We had 1.5 pounds, 1.5 pounds of cashews. And the cashews cost $5.40 per pound. Okay, so these are all the values we're going to need. We're going to multiply each of these results. So 1 pound times $1.25 per pound, right? Make sure all the units match. This is pounds, this is per pound, pounds per pound. Okay, so if we multiply 1 times the 1.25, we'll get how much to be spent on the raisins. Obviously, $1.25. It was only 1 pound. Okay, now if we multiply the 2 times the $3.25, this product will tell me how much I've spent on my 2 pounds of chocolate-covered peanuts, which would be $6.50, right? Because there's 2 pounds, and each pound is $3.25. Plus, and then it's a 1.5 pounds of $5.40. So 5.4 times 1.5 equals to 8.1. So $8.10. That's what this is going to be, and that represents how much money we spend on the cashews. 1.5 pounds is going to cost $8.10. Okay, if we add all of these up, this will tell me the grand total amount of money spent, right? Total amount of money spent. And at the end of the day, how many pounds of this mix do you have? Well, you bring in these weights. So we do 1 plus 2 plus 1.5. And so this is what you end up getting. In the denominator, you'll end up getting 4.5. Right? So you're going to end up with 4.5 pounds of this mixture. And how much money did you spend total? Well, we spent $1.25 on this. And we spent $6.50 on these guys, right? So these were the raisins. $1.25 on the raisins. $6.50 on the chocolate-covered peanuts. And finally, we spent $8.10 on this, which was the cashews. So we multiply them, add them, multiply them, and add them. So this numerator here is going to be the 1.25 plus the 650 plus the 810. So let me figure out what that is. .25 times 6.5. Okay, 1.25 plus 6.5 plus 810 gets me to 1585. Divided by 4.5. So 1585 now represents the total amount of money I spent on all three items. Good. This is like what you pay at the register, and you ended up with 4.5 pounds of the mixed, and they asked you for the price per pound, so you divide these two things together, and we get 1585 divided by 4.5. I'm getting 3.52. 3.52, and this is dollars per pound. Good. And this would be the X bar little sub W guy. So the weighted average is equal to $3.52. See if the author organized it in a different way. All right, so the author organized it in the exact same way, like this. So that's weighted means. Let's do one more example with weighted means. A very, very popular example of weighted means is to calculate your grade point average. So, an example using GPA. Find your grade point average. So in most schools, we have A's, B's, C's, D's, and F's. F's are worth 0 points. D is worth 1 point. C is worth 2 points. B's are worth 3 points. And finally, A's are worth 4 points. Good? Okay, so if a student, if some student told you, oh, I got an A in my first class, and then I got an A in another class, and then I got a B in another class, and then I got a D in another class, and then I got a C in another class, so here's their full semester like this. Well, it's not fair, right? You can right away jump to connect that it's not fair to compare the A in this class to the C in that class, because maybe this was a much harder class. Maybe it was a lot more work, a lot more difficult. So maybe getting a C in this class is a much it's a much brighter honor than getting an A in this one, right? So we have to introduce units into this. So let's say we create a schedule for a student. Let's say he's taking, I don't know, English 101, and he's taking stats 150, and he's taking stats class in English. Let's say he's taking a history class, history 1A. He's also doing a chemistry class, chem 12C, and then he's also doing a music appreciation class, music appreciation 101, 1, 2, 3, 4, 5, and let's say he's also doing a physical ed class. How about boxing 1A. Okay, so here's a potential hypothetical schedule like this. Okay, so then each class is going to have a unit load. So let's say that the English class is worth 3 units. The stats class is worth 5 units. The history class is worth 3 units. The chemistry class is worth 6 units. The music appreciation class is worth 2 units. And let's say the boxing class is only worth 1 unit. Okay, so how many units is this student taking? A lot. This is a very busy schedule, right? Not recommended. So 8, 11, 17. Here's a student that's taking 20 units. It's a lot, way too many units, but just a hypothetical example. Okay, so at the end of the semester, he's going to get a bunch of grades. So let's say he gets an A in his English class, he gets a C in his stats class, he gets an A in his history class, he gets a B in his chemistry class, he gets an A in his music appreciation class, and sadly he gets an F in his boxing class. Okay, so let's calculate the grade point average. So first of all, the first thing you have to do is use your table to convert each one of these letter grades into a point. So this is going to be A's are worth 4 points, C's are worth 2, A's are worth 4, B's are worth 3, A is worth 4, and an F is worth 0. Okay, so now what we're going to do is we're going to multiply the value of each unit, the units times the point value. So we're going to multiply across and get that this is going to be 12, this is 10, this is 12, this is 18, this is 18, this is 8, and this is 0. And we're going to add all of these down. And so we get 12, 22, 34, 44, 52, 60. Confirm that. I'm too tired to rely on my arithmetic. 12 plus 10 plus 12 plus 18 plus 8, 60. Okay, so a total of 60 points earned as a product, right? So each letter grade was worth was worth either 0, 1, 2, 3, or 4, multiplied by the units, and we get this. Okay, so 20 units taken, 60 points earned. So their GPA, grade point average, is going to be equal to the 60 divided by the 20, which is going to be equal to 3. So in this case, the student has exactly a 3.0. Okay? 3.0, which is about a B average, right? In the scale, in this scale here, it's right around a B average. Let's say that there was a mistake somewhere. Let's say that instead of a C, he goes back and looks at his work and decides, oh, wait a minute, there was something that wasn't graded properly for the final grade, so maybe that gets changed to a B. Let's see how that affects things. If instead of a C, that's actually 3 points now, that means that 5 times 3, that's no longer going to be 10, that's going to be 15. So we add 5 points. That means that their total is no longer 60, it's now 65. So now the new GPA after that correction is equal to 65 divided by 20 units. And that's going to be 65 divided by 20, 3.25. 3.25. So that was a pretty big jump in the GPA. 3.25 is their new GPA by making that little correction there, making that change from a C to a B. Notice that the most impactful thing here, the thing that added the most to their total, was this one, the 18. Even though they only got a B there, there were places where they got A's. They got an A there, they got an A there, but those resulted in less points because the units were smaller, right? So the fact that the chemistry class has 6 units gives it a heavier weight. It's more weighted. It's more valuable. It's rated as ranked as more valuable, more impactful on their grade, because presumably it deserves it. So maybe it's really hard. There's a lot of work. It requires a lot of time. So there's a whole lot of reasons for why we choose units. But the fact that it's got 6 units, it means that it has the most impact on their GPA compared to the other classes. Good. Okay, so that's how we calculate GPAs. Another classic example of weighted averages. Let's go back to our Okay, the last topic of this section is to think about how to approximate the standard deviation from frequency distribution. So again, just like when we approximated the mean from group data, if we approximate it, we're going to lose some integrity, right? We're not going to get a precise, exact answer. We're just going to get, an approximation. And this is the equation that we're going to use. Very, very similar to the equation for standard deviations from before, except that here the x sub I is the midpoint of each class, as opposed to in the standard deviation, the x sub I was each individual point, each individual value in our list. The mu stays the same, that's still the population mean. And now f sub I is the frequency of our result. Good. And then we divide it by the sum of the frequencies. And then divide these two things together, and then we take the square root, and there's our approximation. So just like before, there's a slight difference between the standard deviation of a population, where we divide by that much, and the standard deviation of a sample, where we divide by that much, right? So we do the extra -1 part of it here, if we happen to know that it's a sample from that this is a standard deviation from a sample. Okay, and just like before, your author pushes you to this shortcut equation. And if you're doing it by hand, and if it's a really big table, this ends up being a very nice shortcut, but we're not going to use it. For us, if I gave you anything like this on the test, it would be something really small, manageable, something you could do by hand. So I would expect you to use one of these two formulas, depending on whether it's a population or a sample. By the way, it might be up to you to decide whether it's a population or a sample, so you're going to have to choose one for yourself. Okay, so let's take a look at this example. The National Survey for Student Engagement is a survey that, among other things, asks first-year students at liberal arts colleges How much time they spend preparing for class each week? Okay, so these are tragically terrible numbers here. Um, so this is in 2007. I think this is real data, so there is cause to be quite sad. 2007. How many people? So this indicates that 130 students that were surveyed indicated that they only spend between 1 to 5 hours preparing for class. Assuming these are full-time students, that is terrible, right? Tragic. Okay, 250 say they only spend between 6 to 10 hours preparing for class. Way too low. 11 to 15 hours a week. Okay, 230 students indicated that they spend somewhere in there, somewhere in between there. So keep in mind, just to be clear on what this means, the original raw data, you can kind of imagine it over here, raw data. You can imagine someone out there on campus with a clipboard asking people for to answer this question. Excuse me, do you mind if I ask you, how many hours do you spend preparing for class each week? Somebody said, I don't know, maybe 7 hours. Somebody else said, oh, I don't know, I spend maybe 13 hours. I don't know, I spend about 27 hours. I spend about 3 hours, right? Okay, now what we did there is that this 7 is somebody in here. This 250 people would include this person because they fall in there, right? So their answers were not 6 to 10 hours necessarily. That might have been the question, but that's not necessarily the question. This is more likely the case that they specifically asked them how many hours. So maybe out there somewhere is this ginormous list that has all the original data, and then that data was tallied and then placed in this table. So that's what we're staring at. We don't have access to the original data. If we did, we would be able to find the original exact population mean, and we would be a sample mean, and would be able to figure out the original exact sample standard deviation. But if we only have this table to go by, we're going to have to settle, right, for an approximation. All right, so how do we do that? The first thing we need to do is that we need to do the same work that we did before to figure out the mean of our data. Now, they didn't give us the mean, so we're going to have to do an approximation for the mean. So let me go off to the side over here and remember that the mean, and this is a sample mean, is approximated, x bar, is going to be equal to the sum of the midpoint values times their frequency values divided by the sum of the frequency values, like this. I would recommend that we create like a nice little table to organize our data. So I'm going to have the classes go over here. I'm going to put them from horizontal to vertical is basically what's happening. So I'm going to have 1 to 5 is one of them there, 6 to 10 is over there, 11 to 15 is over there, 16 to 20 is over there, 21 through 25 is over there, 26 to 30 is over there, and finally 31 to 35 is over there. Good. I'm also going to write down the frequencies. So for this group right here, this was 130. For this group, the frequency was 250. For this group, the frequency was 230. For this group, the frequency was 180. For this group, the frequency was 100. For this group, the frequency was 60. And finally, for this last group, the frequency was 50. Okay, so these are my frequency values, where this is I goes from, right, so let's finish this table up. This is going to be guy equals 1, 2, 3, 4, 5, 6. Looks like there's 7 classes we're going to have to deal with. And now, well, okay, 130 students responded an answer that lied in this little classes. So maybe some of them said 1 hour, maybe some of them said 5 hours, some of them said 2 hours. So remember that our best guess is going to be that class midpoint. And that's going to be the x values. X sub I values, which are the class midpoints. And so remember that the formula for the class midpoints is to focus on consecutive lower bound values. So add 1 plus 6, divide that by 2. That's going to be 7 divided by 2 is 3.5. So 3.5 is the middle value here. My best guess is that these people studied about 3.5 hours. Some of them studied a little less, some of them studied a little more, but 3.5 is a very good guess for these 130 people. Next, we look at the class midpoint of the next one. So we're going to add the 6 plus the 11 and then divide that by 2. That's going to be 17 divided by 2. That's going to be 8.5. Okay, so 8.5 is somewhere in the middle here. And that's my best guess for the number of hours studied by these 250 people. For some people, they answered 6, so this would be a high guess. For some people, they answered 10, so this would be a low guess. On average, we're hoping that those two under guesses and over guesses kind of cancel each other out, and that this ends up being a pretty good guess. Good, and so we continue. Let's do one more, and then we start to see a pattern. 11 and 16. Okay, we add 11 plus 16, divide that by 2, and we get 27. 27 divided by 2 is 13.5. 13.5. Okay, so we start to see a pattern. The next one is going to be 18.5. The next one is going to be 23.5. The next one is going to be 28.5. And the next one is going to be 33.5. Right, so just kind of establishing that pattern and then just double check that it makes sense that the 33 lies somewhere in the middle there. The 28 lies somewhere in the middle there. Good. Okay, so now we want to multiply across to get our very best guess for the sum of the hours spent studying for these people. So if we multiply 130 times 3.5, we're going to get the value that goes right here. 130 times 3.5. That's going to be the number that goes right there. 130 times 3.5. That's going to be 455. So that means that my best guess is that if I add up all the hours studied collectively by these 130 people, my best guess that it is going to be 155 hours. Good. Now if we multiply 250 times 8.5, that's going to be 250 times 8.5. I get 2125. Right? So again, that means that 2,125 is my best guess for the sum total of hours spent by these 250 people, where I'm guessing that each one of them studied about 8.5 hours in a week. Right, and 8.5 being the midpoint there. Some people said 6, some people said 10. We're just kind of saying 8.5 is a pretty good guess. Okay, and we keep going just like this. This new column here is going to be the product of these two. Okay, now let's get some technology in our life. Let's do this using column operations like we did before. So I'm going to use my calculator. I'm going to put these values onto list 1, right? Not the classes. I don't want to put that in my calculator. I want to put the frequencies, and I want to also put in the class midpoints. So let's type those in. And now when I put those two columns in my calculator, I can figure out L3 is equal to L1 times L2, and then my calculator will give me all these values automatically. Okay, so let's practice that. Let's go over to our calculator. Okay, you know what? I might need that data. We used it earlier. Who knows? I might need it again. So I'm just going to go over to L3. It doesn't matter. So change of plans. Let's change these things. Hit clear, enter. So I'm going to use L3, L4, and L5. So L3, L4, and then L5 is going to be equal to L3 times L4, right? Oh, you know what? I should have just erased it. That's ugly. So this is going to be L3, L4, and then L5 is going to be equal to L3 times L4. All right, let's type those guys into our calculator. L3 is going to be 130, 250, 230, 180, 100, 60, and 50. Alright, so now I got to type in the class midpoints, and luckily I already calculated them all right there. It's 3.5, and then 8.5, and then 13.5, and then 18.5, and then 23.5, and then 28.5, and then 33.5. Okay, double check that that looks good. Okay, so now I want to multiply L3 times L4. Let's go over to L5. Make sure you go up to highlight L5, and now you can do column arithmetic. So we're going to type in L second L3 times L4, enter. And there's the results, right? So it matches with the first two that I was getting. 455, 25, okay, so 21, 25. So it matches up. So I'm just going to go ahead and write down the rest. Actually, all right, so the next one is going to be 3105, 3105. And the next one is 3330. And then the next one is going to be 2350. And then the next one is going to be 1710. And finally, the last one is 1675. Okay, so this is remember that our mean, this notation here, this means x1 f1 plus x2 f2 plus dot 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 out to the last one. In our little case here, there's 7 of them, so I know the last one is going to be x1, oops, sorry, not one, x7 f7. x7 f7. Okay, well that's what this is. This product right here, this one is the product of each one of these. This one was f1, right, because it's the first one in here. This is f1, and this is x1. So this is x1 f1. This is x1 f1, right? And this one is x2 f2. And so on and so forth. This last one over here is x7, f7. So my point is we need to add them together. We need to figure out the sum of all of these. Good. Well, luckily they're already in my calculator, so that's just the sum of L5s. And so we can take advantage of our shortcuts in our calculator. L5, I want the sum of all the values in L5, so we're going to do stat calculate one variable statistics on L5, and then remember that this is the one we want. This indicates the sum of all the values in our list. So 14,750 is the sum of all those values. 14,750. So this guy is 14,750. That's that total right there. Okay, so up here with our formula, that means that the numerator is 14,750, and now the denominator is the sum of the frequencies. Well, that would be these guys, the sum of the frequencies. So I need to figure out what that is. Well, again, luckily that's already list 3. So if I do a one variable stat on list 3, one of the items I get is the sum of the values on that list, so that would be easy to figure out as well. Right? So we're taking advantage of properties in our calculator. So let's go to stat, calculate, one variable stat, and then list 3. Enter, enter, enter. Okay, and then there it is. And it's 1,000. Oh, I think they had already mentioned that actually, but 1,000. So this whole thing is 1,000. Right? The sum of all these values. And what are these values? Well, this is the number of students. 130 students said that they studied between, when asked how many hours they studied, 130 students answered a value that lands inside this class. 250 students answered a value that lands inside this class. So if we add them up together, that means that there's 1,000. Okay, so this denominator down here, right, this notation means F1 plus F2 plus ... until the end. And as we see here, for our little case, there are 7. And now we know that that is equal to 1,000. So if we divide these two things, we'll get our answer. Okay, so this is going to be, move the decimal over 3 spaces. Luckily, it's a nice 1,000. So this is going to be 14.75 as our answer. Okay, so after all that work, we found the approximate mean for the population, 14.75. Okay, so now let's focus on what they actually wanted me to figure out. Coming back over here, we were trying to find an approximation for the standard deviation of this data, and we're going to do that by using this formula. Okay, so let me back this up again. All right, so we want to do a very similar kind of thing, except to figure this out. So I'm going to create tables. I'm going to create lists again. So okay, that's fine. I'm going to recreate that table once again, this time to figure out the standard deviation, right? And this is a sample, standard deviation of my sample. So again, I have my 1, 2, 3, 4, 5, 6, 7 values there. We have I, and that's 1, 2, 3, 4, 5, 6, and 7. And then we had our classes, just like before. And then we had our frequencies. And then we had another category for class midpoints. These were midpoints, so we used x sub I values. So I'll put up here x sub i's. And these were midpoints. Midpoints. Okay, so the class ran from 1 to 5, and then from 6 to 10, and then from 11 to 15, and then from 16 through 20, and then 21 through 25, then 26 through 30, and then 31 through 35. And the frequency values were, this was 130, this was 250, then 230, then 180, then 100, then 60 and 50, 60 and 50. We did our work to find the class midpoints before as well, so we found that this class midpoint was 3.5, this one was 8.5, this one was 13.5, this one was 18.5, then 23.5, then 28.5, and finally 33.5, right? And then just quickly glance over to make sure it makes sense that this is the midpoint of this class, the midpoint of that class, the midpoint of that class. Good, 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 good. And then also from the previous work right below, we found that the mean approximation was 14.75. Right? Our best guess is that on average, these students study about 14.75 hours per week. Terrible. Terrible, terrible, terrible. All right, so 14.75. Okay, so now we want to follow these instructions here to be able to figure out, oops, this one, right, it's a sample. Follow these instructions to find my, my sample standard deviation approximation. Remember that this notation right here means it's the sum of this multiplication. So I'm going to use column arithmetic to find this. I wouldn't expect you to do all of this work by hand, so we're going to have to rely on it. So the first column we're going to need is that we're going to need to subtract each of the midpoint values minus the sample mean. So we're going to have to do x sub I minus 14.75 in this next column right here. And I'm going to use my calculator in a little bit to do that. So that means I'm going to start identifying what I need in my calculator. So I'm going to put this as list 1 for my calculator, these guys. And I'm going to put these guys as list 2 in my calculator. Then I'm going to subtract each one of these points minus 14.75. So in my calculator, I'm going to do L3 is going to be equal to L2 minus 14.75. Okay, so that'll give me these subtractions. So I'm just going to go ahead and get started on that. Let's zoom in a little bit more there. Okay, let's go over there. All right, let's go over here. Stat, edit. Let's clear out all of this. So clear, enter. Okay, well, instead of doing each one, I can also take this other shortcut, hit stat, and then go down to clear lists, hit enter, and then I think, can I just do it like this? No, it does want me to list the lists that I want to clear. So let me see, does it do L1, comma L2? Can we do that? L1, comma L2? It does. Okay, so then it cleared L1 and L2. L1 and L2. Okay, so now I need L3 and L4, so I don't know if it's that much of a shortcut, but clear lists, and then I would do L3, comma L4, so it should automatically clear those guys. Start edit. Okay, clean start. All right, so let's type in our results. So I'm going to need to put 130 for here, followed by 250 for here, followed by 230 for here, followed by 180 here, followed by 100, there, followed by 60, followed by 50. Okay, so that's all L1. L1 is there. Let me make sure I copied it right. Okay, good. Now for L2, I'm going to put all my class midpoints. So I need 3.5, followed by 8.5, followed by 13.5, followed by 18.5, followed by 23.5, followed by 28.5, followed by 33.5. Okay, so those are all the midpoint values. Next, according to my little formula over there, the next thing I need to do is figure out what this is. So let me scoot this over a little bit. I need to figure out each one of these values minus the mean of the sample. So I'm going to go over to L3. Make sure you go up, highlight the L3, and now we can do a little equation with our columns, column arithmetic. And I'm going to set L3 equal to L2 minus 14.75. Hit enter. So that would be each one of these numbers here minus 14.75. Good. And so now that I have that, I can fill out this column right here. So that's this guy right here. Let's fill it out. That's minus 11.25 minus 6.25 minus 1.25, 3.75, then 8.75, then 13.75, and finally 18.75. Okay, now again, guided by my formula, let's go back over here. We want to use this formula, right? And remember, here, let me expand that just in case it's not super clear. We have S is equal to, and we have X sub I, and then minus X bar, parentheses squared, F sub I, right? That's that numerator. And then we have this notation there. So this means that we, oops, let me squeeze it in a little more. This guy, so this means it's going to be a ginormous sum where we keep taking control of the i's, right? So it'll be I1 minus X bar, parentheses, squared, F1, 1, and then plus, and then again we do it again for 2. It'll be x2 minus x bar squared f2. So that'll be a 2 there and a 2 there. And then we do it for 3, and then we do it for 4, and then we do it for 5, dot, 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 until we end. And where do we end? Well, there are 7 for this example. So there should be a 7 there, and this is from I going from 1 to 7. Okay, so this guy, the very last term, dot, 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 plus the very last term will be x minus x bar squared f of, so this is x sub 7 minus x bar squared times f of 7. And that is what this whole ugly thing is. And then in the denominator, well, we have this whole thing gets divided by, and it's this, and it's the frequencies, sub I, as I goes from 1 to 7. So this part is just going to be the sum of the frequencies, f1 plus f2 plus dot, 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 all the way out to f sub 7. So f1, 2, dot, 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 all the way out to f7. That's the sum of the frequencies. And when you're done with that sum of frequencies, then separate to that is this minus 1 at the end. Once we figure out that whole thing, then the last step, let me make some space here. The last step is to take the square root of this whole thing, right? Minus 1, and then the square root of this whole ugly thing This equals that, and then S equals this whole mess. Okay, so that's what we're trying to do. So I've managed to subtract each of the class midpoints from its mean. That's what column 3 is, right? So column 3 contains the values inside each of these. So now I'm going to do a column 4 using my calculator. And column 4 is going to be equal to column 3 squared. That'll give me these things here. Right, so let me extend this. So we want to be guided by that formula so we know what we need to do, which steps we need to take with our calculator, because we definitely don't want to do all this arithmetic by hand. Okay. So now I need column 4 to be equal to column 3 squared. So go to my calculator. Column 4 is going to be equal to L3 to the power of 2. Enter. And those are all those values. And copy them over here. So what we're doing is that now we're taking each one of these and squaring them. So this is going to be x sub I, each of the class midpoints minus the class mean, which is 14.75 for us, squared. That's what's happening. So the minus 11.25 squared is going to be equal to 126.56. And the minus 6.25 squared, that's equal to 39.063. And then 1.5625. And then 14.063. And then 76.563. And then 189.06, and then 351.56. Okay, so what we've done so far is we've been able to calculate each one of these things here. It's the class midpoint of 1, that's this 3.5 belongs there, minus 14.75, that's the class mean, the sample mean, and squared it. So this whole term right here is 126.56. Good. And then this one right here, this is the second x sub 2, the class midpoint of the second class. That's 8.5 minus the sample mean, which was 14.75. Subtract those, square it, and that's how we get to this number. Okay, so the next thing I need to do is multiply each one of those values by the frequency value. Okay, so I'm going to have this next one represents x sub I minus 14.75 squared times f sub I. Okay, so now using my column arithmetic, this right here, this is L4. So I'm going to say that L5 is equal to L4, that's this guy, times the F, which was way back here, L1. Right? So L5 is equal to L4 times L1. L1 being the frequencies, right? So I want to multiply like this guy right here, this first term, this part right here, all of this is 126, 126.56, and then I want to multiply by the frequency, which was 130. Good. And now the next term, all of this up to there, that is 39.063, and I want to multiply it by its frequency, which was 250. Right, so I want to multiply those two together, and that's the value that belongs there. Multiply these two together, that's the value that belongs there. So let's use our calculator and then we'll confirm. So the formula should be L5 equals to L4 times L1. Go over here, make sure you highlight L5, and this is going to be equal to L4 times L1. Enter, and I get all those values. So let's copy those onto my table. So that means that this value is 16453, and also note that you get kind of cut off there, but if you notice down here, you get the full, the full result, or it goes out to more decimal places if you need more accuracy. And then if I want another one right below it, then I got to use my arrow to go down. And so see, instead of just ending at a 6, I know it's actually 6.25. And then instead of ending in 359.38, it's actually this number. Okay? So if you wanted more accuracy, that's how you would get a more precise answer. So this one is going to be actually 123.125. And this one is 9765.6. 625. 625. And then the next one is 359.375, and then the next one is this over here. Okay, and then the next one is 2531.25. And then the next one is 7656.25. And then the next one is 11343.75. And finally the last one is 17578.125. Okay, so let's go back over here. What we have now is the result of each individual midpoint, right? Here are all the midpoints. Each individual midpoint has been subtracted from, or we have taken away the mean, which is 14.75, and squared it, and multiplied it by the frequency. So far, we have these values. Column 5, let's go medium, let's see. That's a plus. Okay, so column 5, what this column has is that this number, the really big ugly number right there, that's this product right here. This whole thing is in fact the 16453.125. And this whole thing in here is the next one, 9765.625, and so on and so forth. So the last one on here, this last one, is the last one on my column, which is 17578.125. Okay, so as you can see, the next thing we need to do is add all of these values, and that'll give you the numerator of this ugly fraction, right? That'll give us the numerator. So I need to come over here and add column 5. Luckily, that's a really easy, there's a really easy way to do that. All we have to do is do a one variable stat on L5, and one of the results is going to be the sum of all of these values. That'll end up being the sum of this entire numerator. Okay, so we'll go over here. We're going to go to Stat, Calculate, One Variable Statistics. We want to make sure we hit second, L5, down, down, Enter, and then here is the number we want. It gives you a lot of information about L5. It's up to you to decide what you need. And what we need right now is the sum of those entries, which is this one, sum of the X values in the list. So all of those numbers add up to 65,687.5. That's what that lets me know. Okay, so let me copy that down over here. So this entire grand sum total over here is 65,687.5. That's going to be that numerator we need right there. And also, I can see that I'm going to need the sum of the frequencies. The sum of the frequencies is this guy right here. So I'm going to go ahead and do that as long as I'm already here. And that would mean that I need the sum of the L1s. That's all the frequencies. So I'm going to go to my calculator, and I'm going to do the same thing. Go to Stat, Calculate, One Variable Statistics, and this time I want to do it on L1. Go down, Enter, and then I need that. Oh, that's right. They added up to 1,000. We did that before. The sum of the frequencies is 1,000. There's 1,000 students in this survey. So that means that this is 1,000. Good. Okay, so now we have everything we need to finish up this really ugly calculation. The sample standard deviation, right, that's this formula right here, is equal to this. The numerator is equal to this whole thing. But now we have an answer for that numerator. So this whole thing is equal to a giant fraction where the numerator is going to be the number 6,567.5. The denominator is going to be this 1,000. So all of this right here is 1,000 minus 1. So it's really going to be 999. 1,000 minus 1. And when I figure out what that is, I still have to take the square root of that whole thing. Okay, so we're almost there. Well, this last part is easy enough to just do with our calculator now. Let's go over here. So clear over there. It's going to be 65687.5. 65687.5 divided by 1,000 minus 1 is 999. Enter. So that's the result I get from the division, this guy. And now if I want to take the square root of that, I hit second, square root, and then previous answer. And finally, we get to our result. Okay, so all of this, I'm just going to copy it right here. Well, okay, I'll put it here. This is the square root of, and this is 65.7532, something like that. 32. And then I can just conclude that my sample standard deviation is going to be approximately the square root of all that, which is 8.1088. Now tell me that's not fun. Okay, let me come out here. All right, so recap. We need to use this formula to find or approximate the sample standard deviation from grouped data. So we're given this information here where we have classes and we have the frequency in the class. We got to find the class midpoints. Okay. On my calculator, I put it onto list 1. I put all these values onto list 1, these values onto list 2. Then I start doing column arithmetic. List 3 is going to be equal to L2, the class midpoints, minus the mean of our population, which means that we're going to have to do some work to figure out that answer, right? That was the answer we got by doing this work over here from earlier, right? So after all this work over here, we got that the answer was 14.75. So that was a nice adventure onto its own. But once you find that, then you got to come over here and continue with this table. Yeah. Okay, so L2 was the class midpoints. L3 is L2 minus 14.75. Okay, that's all those values. We got to take each one of those and square them. I'm just kind of being guided by our formula. Each class midpoint needs to be subtracted by the population mean, square them, times the frequency. Good. So as we get this column, we got to square this. L3 gets squared. That'll give you each one of these. Then we got to multiply times the frequency. That's this last one. We got to add them together. That'll give you the numerator here. Then we divide it by the sum of the frequencies minus 1. Get the square root of the whole thing, and finally we get to our answer. Okay, so the author provided a very, very similar kind of table. I just thought we'd, kind of recreate the whole thing to see what kind of work goes into it. Sometimes, you just see the whole answer and it seems like no big deal. Or the other way around, maybe it's just so overwhelming you don't even know what happened. So we just took it step by step to recreate it. But this is what the author does. Same thing. So here is our classes. Here's our classes. And then we had frequencies. These were F sub i's. We made that into one of our lists, and these are the midpoints. We put that into one of our lists. So this was like L1 on our list, L2. Now he skipped, oh no, that's not true. L3 is right here. It's going to be each one of these minus the mean from the population. He didn't identify it anywhere, but we know it's 14.75. X bar equals to 14.75. This would either be given to you or, like I said, it's a lot of fun to go off and figure out that on its own. And then instead of doing L4 and L5, he just kind of brought it together. And you can just type it all into one space, right? So you can imagine that instead of doing L4 is this one squared, and then L5 is the squared one times the frequency, you can just type it all into one big happy thing, right? You could say L4 is equal to L3 squared, L3 squared times L1, right? This would be the same thing as what we did. It just saves one of the columns. Either way, we end up with a column that has the exact same values we had. And next we know that if we add them all together, if we sum these up, we'll get the value we need in the numerator. That's this one right here. So the sum of all of these added together, that's when we did the one variable stat. That's equal to this, the 65,687. And then the sum of all of these frequencies, that was the 1,000. Good. And now we do this number divided by 1,000 minus 1. That gives you this number. So this is right now, he's keeping it as S squared. Remember, this is variance. Variance is S squared. Standard deviation squared is variance. So we found variance. Sample variance. Sample variance. But now if we want the standard deviation, we're going to take the square root of it. And so here we go. S is equal to 8.1. I know these are very, very tedious. In this chapter, we're learning how to do it. So yes, you have to do it. There is no further shortcuts. I mean, we have shortcuts. Our shortcuts is our column arithmetics that we use with our calculator. So I don't expect you to do the actual arithmetic of subtracting and multiplying. or even to use a more simple calculator where you do each one of those operations manually, one at a time. That takes forever. So you want to avoid that. You want to take advantage of our column operations, but that is what I consider doing it by hand, doing it the long way. If I presented something like this on the test, I would give you one of these kind of made out tables already for you to fill in the rest. So I would at least give you a table that has the classes, the frequency, and then maybe the rest would be empty. All the other little cells would be empty for you to fill out. And then you would use your calculator and column operations to fill in the proper places and calculate it all out. This is not what we're going to be doing for the rest of statistics. Don't fall under the idea that this is what statistics is and you're going to be stuck doing this kind of thing, tabulating crazy, weird formulas for the rest of the semester. This is just this chapter. We're learning how to do it, how to find it. When we move beyond this chapter, you're never going to be asked to find it by hand. In future chapters, when you want to find the mean or the standard deviation, or even the approximation of the mean or the approximation of standard deviation, we'll just type it all into our calculator and let the calculator do the work. A few fancy steps away, we can easily get the calculator to give us the mean and standard deviation, or the approximate mean and the approximate standard deviation. Okay, so we'll cover how to do that. Well, you don't need to learn how to use your calculator to find the approximate mean and the approximate standard deviation. So I don't want to add extra layers of, to that and confuse you guys. You won't need that in this class. You will need know how to find the mean and standard deviation given a set of raw data points, which we already know how to do. Right? Put them on a list, do a one variable stat on that list, and it gives you everything you ever wanted to know about that. Okay, this is a good place to stop for now then.